Okay, for topic two, we're going to look at something called the Pythagorean theorem, which would ordinarily be kind of grouped in with geometry, but we're going to show it to you now because it's a nice way to incorporate decimals. Okay, so we have to understand like what is the Pythagorean theorem, and the Pythagorean theorem applies to something called a right triangle. Okay, so don't get too bent out of shape if some of this is a little weird. Again, this will make hopefully more sense when we get into our geometry unit at the end of this course. So a right triangle is a triangle that has 190-degree angle. So 90-degree angles you may have forgotten from the last time you were in a math class, but 90-degree angles are those angles that make up like the perfect corner of a square or a rectangle. That's a 90-degree angle, okay? So if you took a square or a rectangle and cut it down the diagonal, it creates two right triangles, okay? Now, the sides of the right triangle that form the right angle are called the legs. So these two sides right here and here, those form that right angle. So we call those the legs of the triangle. And then the side that is opposite the right angle, it's always the longest side of the right triangle, and it is called the hypotenuse. Okay? Now, we use the Pythagorean theorem to find the length of a missing side of a right triangle. So as long as you have two of the sides, we can use this thing called the Pythagorean theorem to find the third, okay? Now, we have this image right here. So if we have any right triangle, okay, so you can see I've got this right triangle drawn here. We've got the legs, we've got the hypotenuse. The Pythagorean theorem basically says if you take the length of one of the legs of the triangle and square it, take the other leg and square it, add those together, it has to equal the hypotenuse squared. So a lot of times you'll see the legs of your triangles called A and B, and then the hypotenuse is called C. So you might be familiar with the Pythagorean theorem as A squared plus B squared equals C squared. This is just what it's doing, okay? Now, we do have alternate formulas because to do this math, it's not like the hardest thing you'd ever see, but it might be like a shave above where we're at mathematically speaking. So we can use these alternate formulas, okay? So if you're looking for the hypotenuse, so like you have the length of the two legs of the triangles, but you're trying to find the length of the hypotenuse, you can say, okay, the hypotenuse is equal to the square root of the first leg squared plus the other leg squared. Or if you want to use the A, B, and C, this would translate to C equals the square root of A squared plus B squared. Now, if you're looking for one of the two legs of the triangle, so you have the hypotenuse and you have one of the legs. To find the other leg, we're going to say that leg is equal to the square root of the hypotenuse squared minus the other leg squared. So let's say that we're looking for leg A. We would say A equals the square root of C squared minus the other leg, which is B. So C squared minus B squared. And if you're looking for leg B, it's going to equal C squared minus A squared and then the square root of that, okay? These alternate formulas are going to generally be a bit easier for us at this point. All right, so I encourage you to know how to use these alternate formulas. They're just going to make life a bit easier, okay? So let's go ahead and look at some examples. All right, I think we have one, two, we have three. Yeah, we have three examples, and let's just make one longer video. I think that'll be okay in this case. All right, so for example 3, it says find the length of the missing side of each triangle, round to the nearest hundredth as needed. Okay, so let's say that this is leg A, B, C. So we want to know what C equals. So if we scroll up, remember the hypotenuse is C. It equals the first leg squared plus the second leg squared, and then we take the square root of that. Or we could say C equals A squared plus B squared, and then the square root of that. Okay? So C squared equals, well, I'm going to take the first leg and square it. I'm going to add that to the second leg squared. So let's see what we get. Well, 12 squared is really 12 times 12, okay? So that ends up being 144. Something like this, you are welcome to use a calculator. You have to show me the steps I'm showing you right here, but you could certainly use the calculator for like 12 squared if you don't know it. 16 squared, I think I know it, but let's say we use the calculator. So 16 times 16 is 256. Okay. We want to add, okay, we're basically doing the order of operations. So we're treating this radical symbol like a grouping symbol. So we've taken care of exponents. Next, we want to take care of addition. So I think 144 plus 256 is 400, but we can use a calculator to add. So 144 plus 256, definitely 400. And at this point, you have to remember, you have to evaluate the square root. So we can do this two ways. We can go to our multiplication table or we can go to our calculator. So for the calculator, remember, I need to get to this hidden radical symbol, the square root symbol. So I go second x squared, and then I type in 400. This is a perfect square. We've actually seen this already in this worksheet. We get 20, okay? So back to the worksheet, we would say that the hypotenuse is 20. So this is 20 feet as our final answer, okay? Let's do part B. So in part B, we have the hypotenuse and we have one of the legs. We need to figure out the length of the other leg. So let's go ahead and say this leg is A. We know the hypotenuse is C. That means we're looking for B. What does B equal? And if we go up a little bit, we said if we're looking for a leg of the triangle, it's going to equal the square root of the hypotenuse squared minus whatever the other leg is squared. So I also said you can split it as A and B for the leg. So if we're looking for leg B, it equals the square root of C squared minus A squared. So let's look at that. So we have B equals the square root of C squared minus A squared. So let's see, 12 squared is 144, 10 squared is 100. So we get that B is equal to the square root of, well, 144 minus 100 is 44. And this is not a perfect square, so we're definitely going to go to the calculator. Let's see, the directions told us round to the nearest hundredth as needed. So we want two decimal places in our answer, okay? So we're going to go to the calculator and type in the square root of 44. So second x squared, I'm going to type in a 44. Remember, your calculator may be totally different, so you may have to ask your instructor how to use your particular calculator. But we have the square root of 44, and we want two decimal places. So I've got 6.63. The first 3 is the rounding digit. To the right of that, I have another 3, which tells me to round down. So I'm just going to get approximately 6.63. All right, make sure you use the squiggly equals, the little like curvy equal sign mean approximately equal to. That tells the reader, hey, we had to round at some point. So we're going to get approximately 6.63 centimeters, and that's our final answer. Okay? Now for example 4, it's going to be basically the same thing, but this time we're going to have to draw our triangle. So example 4 says draw each triangle described and then find the length of the missing side, round to the nearest hundredth as necessary. Okay, so for part A, we want to draw a right triangle. We are told that we have the length of the two legs of the triangle. So remember, the legs make up that right angle, that perfect corner. Okay, so we'll say leg 1, we'll call it A. It is 30 inches. And we'll call leg B 15 inches. It doesn't matter which one you label A or B, really. And then the C, or the hypotenuse, we're going to label C. So we're looking for the hypotenuse. So remember, if we scroll up a little bit, the hypotenuse is equal to the first leg squared plus the other leg squared, and then you take the square root of it with just letters and symbols. We have C equals the square root of A squared plus B squared. So let's fill that in. So we have the square root of A squared plus B squared. So 30 squared is 30 times 30, or 900. So hopefully you've got a calculator out with you. 15 squared, I think, is 225. So 15 times 15 is 225. Now we need to add those. So C equals 900 plus 225, or 1,125. Don't stop here. This is a common mistake with students. They stop at this point. No, we need to know what C equals. So we want to go ahead and evaluate the square root. So let's go to our calculator. So we want the square root of 1,125. So I'm going to go second x squared, 1,125. And we're going to go two decimal places. Remember, the directions said round to the nearest hundredth. So I've got 33.54 is in the hundredths place. To the right of that, I have a 1, which tells me to round down. So I'm just going to get approximately 33.54. So this equals approximately, see, let's use the wavy equals, 33.54, and our unit is inches. Okay? So for part B, we're going to draw another right triangle. So you can just draw it however you see fit. Just make sure you got your right angle in there somewhere. We know that the hypotenuse is 9 centimeters and one of the legs is 8 centimeters. Does not matter which. So let's say B is 8 centimeters. So if you're missing the length of one of the leg sides of the triangle, let's go back up to our formulas. Remember, if you're looking for the length of one of the legs, it equals the square root of the hypotenuse squared minus the other leg squared. So symbolically, we can have A equals the square root of C squared minus B squared, or if we're looking for B, B equals the square root of C squared minus A squared. So we're looking for A. So I'm going to say A equals the square root of C squared minus B squared. So 9 squared minus 8 squared. So A equals, let's see, 9 squared is 81. 8 squared is 64. So we have to figure out what 81 minus 64 is. That's 17. And remember, don't stop here. Common mistake. Students stop one step too early. We want to figure out what A is. Go ahead and evaluate this all the way through. So we want to figure out what the square root of 17 is. So we go to the calculator. We don't love our technology setup, but we use what we have, so we'll keep switching screens. So we have square root, so second x squared, square root of 17. We want 2 decimal places, so I've got 4.12 is in the hundredth spot, and to the right of that I have a 3, which tells me to round down. So we're going to say this is approximately 4.12. So approximately 4.12 centimeters. So 4.12 centimeters. And then over here we had 33.54 inches. Okay? So that's the basic Pythagorean theorem. There are loads and loads and loads of real world examples where you can use the Pythagorean theorem. So I've got 2 of them down here. So let's go ahead and do these 2 in this video. It'll just be a little bit of a longer video. So example 5 says, draw a picture and solve. A lot of times when you're dealing with problems like this, if you can draw a quick picture, it helps you understand like where the different pieces go. Okay? And then we're going to round to the nearest hundredth as needed. Okay? So Jane wants to replace a net on a basketball hoop that is 10 feet high. If she places the ladder 4 feet from the base of the hoop, how long must the ladder be to reach the hoop? Okay, so we've got our basketball hoop here. We're going to say the actual hoop with the net is like this. Okay, so we know this height right here is 10 feet. Now, if I were to lean a ladder, it's going to create, well, that's not very good. It's going to create a right triangle with the ground. So this is my right angle. We were told that we're going to be 4 feet from the base of the hoop. So this is like the base of the hoop right here, this right here. So we're going to make this distance from the base of the hoop to the end of the tilted ladder 4 feet. So what we're really looking for is the hypotenuse. How long must this ladder be so that we can reach the top of the hoop? Okay, so we're looking for the hypotenuse, which we know is C. Okay, so C equals the square root of the first leg squared plus the second leg squared. So C equals 100 plus 16. So 10 squared is 100, 4 squared is 16. So C is going to have to equal the square root of 116. So we want to take this all the way. Let's go ahead and estimate this on the calculator. Remember, we're going to round to the nearest hundredth as needed. Okay. So if I go to the calculator, there we go. So if I go to the calculator, we want the square root, so second x squared of 116. Remember, your calculator may be different, so you may have to talk to your instructor about how to use your calculator if you don't know. So square root of 116, we get 10.77. That second 7 is in the hundredths place. To the right of that, I have a 0, so that tells me to round down. So we're going to say the ladder needs to be 10.77 feet tall, or long, I guess we should say. So we get approximately 10.77 feet. So we would say something like the ladder must be 10.77 feet long. And that would make it long enough to reach the hoop. Okay? Finally, we have a wheelchair ramp is constructed to rise 1 foot off the ground and extend 13 feet. How far along the ground will the ramp reach? Okay, so we have 1 foot right here, and then we want the ladder itself to be 13 feet, or not the ladder, the ramp itself to be 13 feet. So how far from the ground, or how far from along the ground is this ramp going to have to reach? Okay, so we want to know what this distance is here. So let's say this is A, and we'll say this is B. So we're going to get B equals the square root of 13 squared minus 1 squared. So B equals the square root of, well, 13 squared is 169. 1 squared is just 1. So B equals the square root of 168. And I feel like this one may not round quite right, so let me go to the calculator. So we want the square root of 168. So the square root of 168, we get 12.96, and we want to round to the nearest hundredths place. So that 6 is in the hundredths place. To the right of that is a 1, which tells me to round down. So we would say that this ramp needs to be approximately 12.96, I think it was. Let me check really quick. Square root of 168. Yeah, 12.96 feet along the ground. Okay, so the ramp itself has to be 13 feet long. That means from here to here, we need to be a distance of 12.96 feet. So almost 13 feet, but a teeny tiny bit less. So there you have it. That is the Pythagorean theorem. So you've seen how to do it with pictures, how to draw pictures, how to do word problems. Just make sure you know how to evaluate a square root on your calculator. So play around with that or ask your instructor. Whoops, there we go.